All right, today we're going to look at 10-4 inverse of a function. Now remember, inverse means opposite. So if I'm looking for the opposite of x, that would be, well, y. So in order to find the inverse, my x is going to become y, and my y is going to become x. So we're going to swap those two to find the inverse functions. So if I look at the inverse here, the inverse of -2, 6 is 6, -2. The inverse of 1, 5 is 5, 1. The inverse of 4, 4 is, well, 4, 4. The inverse of 7, 3 is 3, 7. And the inverse of 10, 2 is 2, 10. Now, if I take a look at it at the chart, remember my input is x, my output is y. So all we're going to do is swap these. So my inverse relation would be 2, 0, 4, 2, 6, 4, 8, 4, 10, 2, and 12, 0. So we're just swapping the x and y values here. All right, so let's take a look at something a little bit different here. What I want to do is just solve for x here. Now you'll understand why in just a second. Now I know that y is the same as f of x. So I have y equals 3x minus 7. So here I'm going to solve for x, which means get x by itself. So I have y plus 5 equals 3x. Divide both sides by 3. So x equals y plus 5 divided by 3. Now my next thing I want to do here, it says find the input when the output is 4. Well, if you recall, input is the x value, output is the y value. So this is telling me that y equals 4. I want to figure out x. Well, what's nice is I already have x by itself here. So I have x equals 4 plus 5 divided by 3. So x equals 9 divided by 3, leaving us with x equals 3. So the input here is 3. Okay. All right, well, let's take a look at finding the inverse of these functions. So I want to find the inverse of this. First of all, is this a function? Y equals 3x plus 4. Well, that's actually a linear function. Well, in the past, when we just swapped our x and y values, we're going to do the same thing here. Our inverse, again, we're going to swap x and y and x. So if I've got y equals 3x plus 4, I want to swap my x and y. So I have x equals 3y plus 4. So that's my step 1. We're going to switch the x and y. Now, my last thing I need to do is solve for y. So minus 4 for both sides. So I have x minus 4 equals 3y divided by 3. So I have y equals x minus 4 divided by 3. So this here is the inverse. All right, now let's talk about quadratic functions here. So it says find the inverse of f of x equals 1/2 x squared, where x is greater than or equal to 0. Then graph the function and its inverse. So let's take a look. So I have y equals 1/2 x squared. I want to swap my x and y. So x equals 1/2 y squared. Remember, I want to get y by itself. So I'm going to multiply both sides here by 2. So I have 2x equals y squared. The next thing I'm going to do is square both sides. So I end up with the square root of 2x equals y. So let's get out our graphing calculators here. So I have y equals 1/2 x squared, and then I have the square root of 2x. So let's graph that and see what happens. Now, be careful because notice the parameters on this. So I'm only looking at this side because I want all the values where x is greater than 0. So if I look, we both have a 0, 0, and then they're also at 2, 2. And I'm going to need another point here. So I'm going to go to second table because I want to graph this. 2, 2, let's see. My first one is 4, 8, so that's 4, 8. And then, let's see, I've got 8, 4. Notice those are inverses. So I've got this function here and this one here. So this is y equals 1/2 x squared, where x is greater than or equal to 0. And this one right here is my y equals the square root of 2x. Now, one of the things you have to remember, with a function, in order to make it a function, it has to pass the vertical line test. Meaning, if I draw a vertical line, it's only going to cross one point. Now that's for the function. Now for the inverse, what all this is telling us, right up here, for a function, it's got to pass the vertical line test. Now, for an inverse, it needs to pass the horizontal line test. Meaning if I cross and make these vertical lines, or the horizontal lines, I'm sorry, it's only going to hit one point. So let's take a look here. First of all, it says consider the function. Determine whether the inverse of f is a function, then find its inverse. So if I have y equals the square root of x minus 3, yes, this is a function. Okay? Now, I want to find the inverse of this. Okay, notice I'm looking at this function. What would be the inverse of this? So if I were to graph that and go back to y equals, let's clear these out. So if y equals the square root of x minus 3, this is my original function. Does it pass the vertical line test? Yes. Now, my other function, the inverse, needs to pass the horizontal line test. So let's figure out what that is. So we're going to swap our x and y's. So here's our inverse. So I've got x equals the square root of y minus 3. So how do I do that? I'm going to square both sides. So I have x squared equals y minus 3. Then add 3 to both sides. So here's my function, y equals x squared plus 3. Now let's graph that. So y equals x squared plus 3. Uh-oh. I don't have an inverse function because it doesn't pass the horizontal line test. So what can I do to this to make it a inverse? Now think about it this way. If I said, what is the opposite of the left side of the apple? You're going to say the right side of the apple. You're not going to say the whole apple. So I'm only looking at half this function. Well, here's the question. Which function am I looking at? Well, if I look at a point here, I've got 1, 2, 3, 4, 5, 6, 7. And this part right here, 7, 2. So what would the inverse of that be? Well, that would be 2, 7. So it's 2, 1, 2, 3. So I'm right about here. This is 2, 7. So I know I'm going to look at this function right here. So how do I get rid of this? Well, I need to cut it off. And how do I do that? All my x values must be greater than or equal to 0. So I have x greater than or equal to 0. Now what that does is allow me to only have this part of the function. If I remove this part, it's now going to pass the horizontal line test. So now I've got my graph, and there's my inverse function. These two should look the same. If I were to have a parabola, they're definitely not going to look the same.